Good morning, students. Thank you so much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the number of electrons transferred, n value. Okay, na? N value, number of electrons transferred from anode to cathode. From anode to cathode. This topic is from electrochemistry lesson. So, students are facing here to calculate the number of electrons in these two formula, students. Delta Rg naught is equal to minus NF E naught cell. E cell is equal to E naught cell minus 0.059 by N into logarithm of Zn plus 2 by Cu plus 2. So in this formula and here in two formulas, Nana, N is there, small n. What here N indicates, students? Number of electrons transferred. Number of electrons transferred. So in the cell reactions and cell representation, students are facing very difficulty to find the number of electrons. So n value, what is n, students? Number of electrons transferred. Clear? Electrons transferred. Right. Now see, students, here how to find, this is the cell reaction. Here in this reaction, suppose we want to find delta Rg naught value. Here n value we want. Yes, so in the problem they will give E naught cell, Faraday's constant. N value we have to find from the equations, from the cell reaction and from the cell representations we have to find n value. But in the questions they will not give n value is 2, 3 like this, they won't give, students. How to identify, how to find easily number of electrons transferred from anode to cathode? Are you following? So how to find n value? Now I am going to discuss, students. N value. Okay, this is the n value and this is the n value. Clear this one? So n value in these two formulas we have to find n value. How to find it, n value? See, students, this is the cell reaction. Okay, so in cell reaction, students, in two cases, how to find the I gave two best tricks, students. Is in the previous video I explained, Nana, how to find how to identify which is anode and cathode. Okay, in the previous video, Nana, I explained two best tricks, students, in case of cell reaction, in case of cell representations. Like that, in two cases I gave the two best tricks, students, how to find anode and cathode. Okay, na? So in the case of cell reaction, what is the best trick? NAC. Okay, na? That means neutral atom, anode, cathode. So anode is before arrow anode, after arrow cathode, which is the neutral atom, that is anode and cathode. Okay, now in case of cell representation, students, what is the best trick? ABC trick. What is A? Anode, B is the bridge, C is the cathode. Clear? These two best tricks I discussed in the last video, students. In the previous video I discussed about how to identify anode and cathode. Now in this section, students, I am going to discuss about the n value, how to calculate easily number of electrons transferred. Now see, students, in this reaction, just here zinc is there before arrow, after arrow also same element only you take, students. Zinc to zinc. Are you following? So here zinc is the neutral atom, so here it is the ion. This is atom, this is ion. Same atoms only you have to take, same element, zinc to zinc. Okay, na? So zinc to zinc. Zinc here how much is here? Zinc here right hand side Zn plus 2. Now see, students, here zinc how much charge is there, students? Nothing is there means 0. Okay, na? So here charge is 0, here plus 2. Here just you subtract big number minus small number, students. That is 2 minus 0. That means 2. That means n value how much, Nana? 2. That means 2 electrons lost. So we know that in the cell reaction, zinc is the anode, silver is the cathode. So at anode we know that oxidation reaction takes place. That means electrons will be lost. So 0 to plus 2 means zinc here oxidation number 0, here plus 2. That means 2 electrons lost. Okay, now 2 electrons lost. That's the n value 2. Just what you have to do, students, here, which is the neutral atom? Zinc. Here, left hand side arrow, take zinc. Right hand side arrow also, you take the same atom, zinc only. Zinc to zinc. Are you finding, student? Are you understanding, students? Zinc to zinc. Here 0, here plus 2. Big number minus small number you have to do, then you will get the n value. Over. Now see, students, here this one, second example, see here cell representation is there. Cell representation, here how to find it? We know that this is the cell representation, this is anode, this is the bridge, salt bridge, this is the cathode. So here you have to take same element only, you have to take copper to copper plus 2. I am taking Cu to Cu plus 2. Okay, same element only you have to take. Understanding? Copper to copper plus 2. Copper to silver you should not take, students. Okay, copper to copper plus 2. Here how much charge, nana? 0. This one plus 2. Clear this one? Cu 0, Cu plus 2. Now here just you find n value, big number minus small number. 2 minus 0, 2. Here also n value 2, nana. Now see, students, in the third example, here also this is the cell representation. This is anode, this is the cathode. Are you following? This is anode, this is cathode, this is the salt bridge. Clear? This is the salt bridge. Okay. Now in this reaction, anode, first you, in the cell representations only anodes you take, students. At anode we know that oxidation reaction takes place, 2 electrons are lost. These 2 electrons are transferred from anode to cathode. How many electrons lost? That only transferring from anode to cathode, students. Okay, Nama. Now here anode, same element to element. So zinc to Zn plus 2. Zn to Zn plus 2. Kada? Here Zn, here Zn plus 2. This is 0. That's why n value how much? 2 minus 0. How much, nana? N value 2. Clear this one. Now see, students, example 4. In example 4, 3 Mg plus 2 Al plus 3 gives rise to 3 Mg plus 2 aluminum. This is the cell reaction. Now we know that this is magnesium is anode. So at the magnesium electrode, oxidation takes place, electrons lost. These electrons are transferred to the aluminum cathode electrode. Okay, how to find it n value? Here magnesium is there. Same element. Here before arrow, magnesium taking, after arrow magnesium only take, magnesium to magnesium. Are you following? Here first you have to take neutral atom, after that charge you have to take. Are you clear, students? Here neutral atom, here charge. So that's why here neutral atom, what is there? With the number of moles you take, students. 3 Mg gives rise to how much, nana? Here 3 Mg plus 2. Clear this one? This Mg plus 2 with the number of moles. Here how much, nana? 0 kada? Oxidation number, here plus 2. Now you have to find n value. Now tell me, students, here just here number of moles, here how many, nana? 1. So 1 into 0, 0. 1 into 2 plus 2, like that. Here in this example 3 moles, here 3 moles are there. That's why 3 into 0, 0. Here 3 into 2 plus 6. Are you following? 3 into 2, 6. So here plus charge is there, plus 6. So here how much, nana? 3 zeros are 0. 3 into 0. Here 3 into plus 2 plus 6. Are you following? 3 into plus 2 plus 6. Here charge how much? With the number of moles you have to multiply the charge. 3 into 0, 0. 3 into plus 2 plus 6. Now how much n value? Big number minus small number. 6 minus 0. How much, nana? 6. So n value is 6, students. Okay. Now see, in this case, last example, students, magnesium to magnesium I am taking. So magnesium 1 mole only is there, Mg plus 2, here also 1 mole only there, Mg plus 2. Now here charge is 0, oxidation number 0, here plus 2. What is n value? 2 minus 0, big number minus small number, n value is 2. Understood, students? This one how to find it? Okay, now clear this one. So here how to find it, students? N value, how many electrons transferred? Easy, students, it is very easy. Just you try to understand. Just I am taking the cell reaction here. Here zinc to Zn plus 2. Here first neutral atom take, here ion take, but both should be same element you have to take. Zn to Zn plus 2. Okay, and here in the second example, here this is cell representation. Are you clear? This is which one, students? Cell representation. Clear amma? Cell representation. So in the cell representation, what is the trick, students? ABC trick kada? We discussed ABC trick. Okay, which is anode, which is cathode. This is anode, okay, and this one is cathode. Clear? Anode to cathode. Now copper to copper plus 2. This copper to copper plus 2. So that is copper 0, this plus 2, that n value, this minus this n value you will get. That much only. In the cell, this is also cell representation. This is anode, this is cathode. This is 0. Zinc to zinc you are taking. Here same element you are taking. Zinc, 0 plus 2. Okay, now how much, students? N value 2. In this case, with number of moles you have to take 3 moles. 3 mg plus 2. Magnesium, same element to same element. Are you following? So mg to mg plus 2. So n value 6. In this case, mg to mg plus 2. So big number minus small number you will get. Understanding? Okay. Thank you, students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.